going to start out with Peter kind of summarizing this kernel design discussion for the longer term, and then you know, Kathy and I have kind of been talking about how to make sure it merges together from the short time scale and the long time scale, and I'll try to say something about that and just have some kind of general things that people can react to, and maybe we can change it kind of on the fly. And then after the break, there's time for people to kind of organize and figure out what they're writing up. And if you've already gotten something written up, you can give it to Kathy or me, or you can work on writing up what you need to write up, or talk to other people if there's questions about what you're writing up. And then this afternoon, we'll come back and try to put together some executive summary points. And so we'd like everybody to be kind of thinking today about what they think kind of major kind of conclusions or executive summary points could be for this thing we're going to write up that would be carried forward to the WGCM Games meeting. So take it away.
Okay, thanks.
There you go.
Thanks. Jerry's actually clarified it in my mind as well by producing these plots. The basic issue then is that we want to come up with an experimental design that really meets two main criteria, I think. The first one is that we'd like an experimental design for including, in this case, the carbon cycle that doesn't exclude people, A, that don't have a carbon cycle, or B, that wanted a carbon cycle but didn't quite manage it, so that you don't have to risk a lot in running with interactive CO2. And the second and more important criterion, I think, is that from a policy perspective, it's more and more important for us to look at what we need to do to avoid certain degrees of climate change rather than to do in an interactive sense what's the consequence of a given emission scenario. So for those reasons, this experimental design used a prescribed CO2 concentration scenario. In that sense, it's like an old-fashioned type experiment that we do. Okay, the coupled climate carbon cycle experiments I spoke about on day one used a prescribed emission scenario, which means CO2 varies interactively, and you don't really know where it's going to end up. These ones used a prescribed concentration scenario, but they still calculate fluxes consistent with the climate change. Okay, CO2 varies in a prescribed way through the atmosphere. The climate changes in the way it would normally do. That influences the land surface and the ocean uptake, and you diagnose those fluxes, those land and ocean fluxes, including land use. What that means is that you can diagnose the implied emissions associated with this concentration scenario, okay, which is an important thing from a policy perspective. Essentially, do it in a different colour pen. The rate of change of CO2 in this, which is prescribed, is the fossil fuel emissions or the non-land use emissions. Let's call this emissions minus the uptake of the ocean atmosphere flux, minus the, that should be the other way around, land atmosphere. Okay, and these things we're going to calculate in the model interactively. These are a function of climate. This is therefore, this we're prescribing, this can therefore be diagnosed. And essentially we will have an emission scenario that comes out of this, which is essentially consistent with the concentration scenario we've prescribed, or rather working group 3 have prescribed for us. Okay, now this could be a stabilization scenario, it could be a reference scenario. The same thing would apply. So what that does is basically say, for each of these coupled models, we will, yeah.
I would reverse that. I mean, we're prescribing DCO2 DT.
Yeah.
The models are responding with the two fluxes on the right.
Yeah.
And then you invert. Then you
quite.
You subtract again.
That's why you tell your fossil fuels on.
Yeah. Isn't that what I said?
Yes. Yeah. Oh, sorry. Just
sorry. Yeah. Circle. All right. So this is all right. All right. This is prescribed. Let's do it this way. Prescribed. Calculated.
Okay. Diagnosed.
Yeah,
diagnosed. That's the right word.
Okay. Diagnosed. Yeah. Okay. Yeah.
I'm sorry.
No, I may not. I just circle things inappropriately, but that's basically what it is. You would, yeah.
In stabilization, presumably all those balance.
In the end.
Is that where you're counting?
In the end, of course, yeah.
Oh, they balance at all times.
No.
Yeah, they do.
The time rate of change is required to balance it when carbon CO2 is
right. Yeah.
increasing.
This always applies. This equation always applies, but in stabilization, this turns 0. Okay. Yeah.
In this approach, is CO2 the only thing that's going to be varied? No
No.
methane, no aerosols?
No, we're going to have to. I think we would have. we're going to use prescribed concentrations for those as well, because they, by changing the climate, they change the fluxes. So
Also, I presume not prescribed concentrations of aerosols. You would probably do emissions of aerosols.
I think we do those in the way we would normally do them in the models, which is generally interactive.
Yeah. So you prescribe emissions.
The models are as they are now, except some of them have an interactive carbon cycle, which is used diagnostically.
Well,
Okay.
some of, well, let's actually, I'm not quick there on the aerosols, because some of them can take emissions and go to concentrations, and then some of them need prescribed aerosol loadings.
Sure. In that sense, we're not going to change. I mean, models will do what they always did in that respect.
Both. The point is, we'll need both inputs, emissions and concentrations.
For aerosols. Yeah. And in fact, I would propose that we in the write-up we've done on the carbon cycle and DGBM, we also want both emissions and concentrations for these runs as well. So we can diagnose.
And the other trace gases like methane, would that be prescribed concentration?
Yeah. That's the proposal. Right. Okay, so this is for example, a stabilization scenario that these guys would produce that would have scenarios for each of the major radiative forcing agents, and then we put them in this and diagnose what the implications are for the carbon cycle. Right, so that's the first thing. That's fairly straightforward. That's run pretty much the experimental design we already do with prescribed concentrations, except that we would diagnose the impact of climate change on the carbon fluxes and therefore could diagnose the implied emissions. Yeah? Fair enough?
And in a sense, you might, some of the models, well, maybe not in this generation, might be the same for methane.
Yeah. Yeah, you could do it for methane. It's slightly harder, but yeah. No? Ron?
One thing that's missing from this design,
Yeah.
and it's just be noted, I guess, is that you don't get the feedback of the carbon on the climate itself. You're breaking that feedback loop.
Well, okay, I'll come to that now, shall I? And we still want to diagnose the feedback, and you have a choice about how you define the feedback. You know, if you do a linear feedback analysis, you can pretty much choose any of the output variables, and it will give you a feedback estimate. In this case, we do a second run. Yep.
I should finish my point on that. A lot of them didn't say it. For the IPCC, they're going to be interested in projections. And they're probably, I was wondering if they were going to be happy with not, in a sense, having the temperature changes due to that feedback.
Okay, I'll come to that in a minute. I suspect that we're interested in temperature change. I suspect policymakers are interested in what you have to do to avoid them. I think there was a difference there. And this is a change of way of doing things, and that you turn the thing and say, okay. But Jerry was saying the same thing. There is a third run you can do if you want to, which would allow you to do that, right?
And the
Straightforward.
alternative is you can use simple models or emix to do the temperature changes, which are,
But you can do a third run as well, and I think most modelling groups would do a third run, in part to check that this kind of prescription of CO2 is okay and that your model doesn't go unstable if you actually put the fluxes back in. But in part because you want to do that delta T. So I'll come to that in a minute.
Right.
I mean, the first thing is that if you consider your major output here the diagnosed emissions for stabilisation, say, or a particular concentration scenario, then what you want to know is what do the feedbacks do to that output. And the way you do that is to run again, but with two CO2s here. One CO2 that's the radiative CO2 that's fixed, okay, so there isn't any climate change, and one CO2 that the carbon cycle sees. This means the carbon cycle is seeing CO2 increase and climate variability, but not climate change, okay? And that the difference between those two runs is essentially your carbon cycle feedback. That's the difference between the carbon cycle seeing this climate change and not. Yeah. So you do exactly the same thing. It's exactly the same experimental design. Temperature has variability, but doesn't have a climate change in it. And you diagnose.
You will have some.
Because
the vegetation will respond to the CO2,
okay.
so you will see some changes.
You'll get some
in the water
biophysical.
fluxes.
You'll get some biophysical feedbacks. There's still an issue about what groups do with that, and you may want to leave that open. Some groups may be able to disable that biophysical feedback. Some may choose to leave it in.
So is there a reason why you would want to disable the feedback? Or not?
It's really a question of whether you want to include as part of your carbon cycle feedback definition biophysical effects or not. And we could make a recommendation on that was
Yeah, so sort of formally in terms of communication, that delta T flat line, you might have some squiggles or maybe a small drift or something.
It's critically important, of course, that there is variability in this. I mean, otherwise we could run the thing offline. The variability in the system is really important.
But also it might have,
there might be a little bit. There might be a tiny drift here.
Not a drift, but
yeah,
there might be some lane.
Yes, we got like half a degree or something from.
And that would be useful to. I mean, that's a useful output, anyways.
Yeah. Yeah. Okay.
Also, there'll be drift from the physical climate system coming into equilibrium with the historical changes.
Yes.
So there's two kinds of drifts going on. One's caused by the interaction with the vegetation, but the other one's from the physical.
So that's in
climate.
experiment 1 as well.
Right.
Yeah.
So the difference should not.
Okay.
Both of those drifts are in experiment 1.
Right. Yeah.
Okay, so that essentially therefore have a profile for the implied emissions for each of these concentration scenarios with and without carbon cycle feedbacks. Okay, and you can use those to diagnose a feedback factor, just like we did in C4MIP. Except instead of looking at an increment to CO2, you look at an increment to the fluxes. Actually, much more relevant, actually, I think, politically. Now, if you want to do what Ron was suggesting, you do a third run, okay, which is to take the implied emissions from this run, run 2, implied emissions from this run without the feedbacks. So you calculate the implied emissions for the run without climate effects in the carbon cycle, and you stick them back in this run and allow CO2 to vary. Okay, that's your third run. So that means
Say that again.
Okay.
Like I say, I thought
Before
You would get the same result if you really did.
Can I clarify? In run 2,
Yeah.
you've done again dCO2 dt.
Yeah.
You've prescribed that, but this time it's prescribed to be 0. And
Oh no, as far as the carbon cycle is concerned, this is the same prescription of CO2 increase as before. Okay.
okay.
So the carbon cycle sees exactly the CO2 profile. It just doesn't see climate change. So these fluxes are calculated without
And
reference
they're
to climate
again,
change.
they're slightly different.
So you get an emissions profile with the feedback and an emissions profile without the feedback. Yeah.
And this is the part that didn't come across yesterday, was that in that experiment 2, when you fix CO2 in the atmosphere, that's all the atmosphere sees, and so the temperature isn't going to change much.
Right, okay.
But the CO2 concentration you specified from experiment 1, carbon cycle feedback sees that, but the atmosphere doesn't see that increase in CO2. So the carbon cycle is reacting to this change in CO2, but not the change in temperature.
The reason we're doing that is because the carbon cycle feedback is defined as the difference between a carbon cycle with and without climate effects, right? That's all. That's just sort of a definitional thing. But the third run, if you wanted to do it, you diagnose the fluxes consistent with this concentration scenario from this run. Okay, so that's the without feedback run.
Atmosphere.
Okay, yeah.
About the temperature.
You diagnose the fluxes, and you therefore calculate the emissions consistent with that profile. And you stick them back in this run. Okay, and let CO2 vary.
that's emissions.
You put the emissions back in this run. So it's an emissions run. The third run would be an emissions run if you wanted to do it. I consider that wasn't.
The original emissions.
that-
Sorry?
Why wouldn't you use the original emissions from working group 3?
Because they're not consistent with your model. They're
Well,
not
the
exactly
second
like-
one,
Okay.
That's pretty critical because you may not get the same answer.
Yeah, you won't.
well, you
Okay, so-
won't. But why? But what does the second one get you? Other than does that just get you a different estimate of the climate feedback? I mean, it
gets
doesn't
you-
really get you. It just tells you the input. I don't see what that gets you.
Well, it allows you to define the effect of climate effects on the carbon cycle on the permissible emissions. Okay, which I think is quite important.
But you already. I mean, you've already done the subtraction, so that's. I mean, you don't need a GCM to do that. That's sort of a waste of time.
Well,
I mean, seriously, you've already got these two runs.
This is a big difference. No, I mean, this is not a trivial. This is not a trivial response. This is not a global mean response.
I know, but you've already got that difference. So
Okay, what you're saying, Steve, why do the third run?
yeah.
Well, I also think that, but Jerry
This is for
and
temperature.
Ron,
Just to get the temperature
Yeah.
climate response.
you could. That's why I think it would be optional. I don't think you'd need to do it, but it's straightforward to do because you diagnose the emissions from here, you stick them back in here, and you'll get an increment to CO2 here in temperature. Okay, and that's your feedback in terms of temperature and CO2. Now, I think it'll be very similar to the feedback you would diagnose from looking at the implied fluxes from run 1 and 2.
So,
But you could do it if you wanted.
Yeah, I mean, because that's different than what Ron was saying, which is you just put in the original, IM model emissions, which are different, and then you get a spread in different models, which you also don't really need to
You don't get the feedback. You don't get the feedback for your model from that.
Yeah. But I mean, those are things, once you diagnose them, you could use.
Yeah. It's a straightforward thing to do. It just means that third run has to come third.
Well, you can basically, I mean, it doesn't matter for that third run, it doesn't matter which emissions you use, the fossil fuel emissions. If you wanted to use the ones from the
Oh, yes, it
Oh, yeah, it does.
Oh,
It
it
gives you a
does.
different. It gives you a different.
Because you want to
result.
know in your model what climate change does to the CO2 concentration and temperature. So you have to use essentially the same emissions.
Essentially, 1 and 2 give you the climate change, give you an estimate of the climate change feedback on the carbon cycle, and then you're basically feeding it back in to get the temperature response. But that's, you can get that other ways. I mean,
Yeah,
that's
sure,
sort of
I agree.
trivial.
I agree. But there may be things. The difference is that it might well be that this increment here is significant in terms of the regional impacts, and you would have to do that with GCM.
Except on one run, it's hard to diagnose. The difference in regional impact between those 2 runs are, in most regions, are going to be insignificant unless you do ensembles.
No, in our model, the difference between that and that is Amazon and no Amazon.
I mean, I think
That's going to be a rare.
It'd be rare, but there in some models it will happen, and some other regions you might have a drying out of the US and some other. So I don't think you don't need this to do this run, but I think if you want to do a diagnosis of the CO2 and temperature, it's a straightforward extension of the experimental design. Yeah.
Going back to the first run for a moment, people have now diagnosed from the first run what their implied anthropogenic CO2 forcing was.
Yeah.
That can be compared with what Working Group 3 wanted it to be.
Yeah.
And let's say it's off by some amount.
Yeah.
If you then say, okay, instead of using my implied value, I really would have liked to use the Working Group 3 value.
Right.
You can take that difference, add it to the calculated terms on the right-hand side, get a new dCO2 dt, and run that, which would then give you the real, what Working Group 3 really wanted the anthro to be, plus what the model's actual feedbacks were, at least from the previous experiment. Because as it is now, we end up with the different models presumably not really using the anthro component that Working Group 3 wanted them to.
Well, no, but from the perspective of my perspective of this, I want some slightly idealized profile of stabilization or concentration profile, right. And I think it's rather useful if we can then feed back to Working Group 3 and say, hold on a minute, guys, what you'd assumed you had to do to stabilize is different in these models.
Right.
And I can give NACI back some sort of fossil fuel emissions or Steve, and they can say, look, guys, this means something else. You've got to do a lot of biomass accumulation in this model, and you haven't got to do it in that one.
Right.
And for a subsequent Working Group 3, Working Group 1 feedback, we'd have a modified set of scenarios,
right.
which potentially could be model dependent.
Yeah.
Yeah.
I understand that, but one could, without too much trouble,
sure.
take the anthro that Working Group 3 really wanted it to be, see how we failed to produce that, then augment our dCO2 dt with what Working Group 3
does that mean,
really
though?
wanted.
What does that mean? I don't think that means anything, because the Working Group 3 would have made an assumption about carbon cycle feedbacks. All it says is that they've made an assumption about carbon cycle feedbacks not consistent with this particular model, I think. Yeah.
Experiments 1 and 2 will give you 2 different sets of emission fluxes.
Oh yeah,
exactly.
Very important.
So,
And the difference
so the
tells you
importance of
something.
doing the third experiment is a consistency check. I mean,
It does that as well.
It's
it does that
actually
as well.
not-
it's important.
It's not entirely in a consistency check because you're allowing your feedback, you get a different
Well,
result.
experiment 1 gives you
The only-
emission flux with feedback.
The only
Okay. Norm, in order to do the consistency check, you'd have to put the diagnosed emissions from this run back in here and prove that you still follow
Well,
the
that,
CO2
that
scenario.
also.
Yeah.
Yes.
But I suspect
That
modelling
may
groups might
be
do
a
that. They
check
might
on
not.
stability, but
It's a lot of rough.
Yeah.
but you know,
I have a different suggestion for experiment 3 or an alternative in that, okay, so in your model, when you do that, at some certain level, I mean, basically what's happening is it's nothing to do with carbon cycle feedback in some sense, well it is, but I mean, basically what it's saying is that at the solid line, at that level of temperature change, you don't get, a certain effect, and then at a slightly higher level of temperature change, you do get an effect, essentially.
What do you mean the difference between these 2 lines?
Yeah. basically at the lower level of climate change, you don't get a certain effect, and at a higher
Well,
level
not
of climate
necessarily.
change,
Not necessarily. It's a possibility.
but that's all that's changing. I mean, in the second one, you have different
No.
fluxes going in, and you have a higher level of
Well,
temperature
this is
change.
okay. This is indicative of the fact that climate change reduces the ability of the land and ocean to take up CO2 in this case. So.
But it's not. But it's still.
It's a feedback. It's just an estimate of the feedback in terms of temperature of CO2 for a given emission scenario.
But the interesting thing is not. I mean, you've already diagnosed the level of feedback from the difference in 1 and 2, so that gives you the fundamental information on the level of the feedback. So all you're doing when you do the experiment 3 is you're saying, well, at one level of climate change of forcing, you get these effects on the ecosystem, and at a higher level of forcing, which happens to be an increment in your model of feedback, you may get more effects. So I would say that's the more important result. I mean, sort of putting the feedback in, saying it's this much delta T. I mean, that's
quite important from a physical climate modelling community perspective, though.
I don't. Well,
it is, Steve, because essentially we've been banging away for ages to say that this matters for the physical climate system. And
but you could diagnose that. I mean, basically, you're running a bunch of computer time to do something you could calculate, roughly offline. I mean, it's not really.
I agree.
Sort of a waste of time.
That's why it would have to be optional. But I think there are modelling groups who would want to do it.
Okay. Well, let me propose something that I would see as more helpful, in terms of understanding impacts or to policymakers. Okay, from my point of view, and that is if you just did a couple optional scenarios like one with different stabilization levels. Because then what you have is between different models, you have a direct comparison of at this level, this model shows these ecosystem impacts. At this level, you can compare the difference in ecosystem impacts in different models, and I think that would be much more valuable.
Okay, but
we already have that in the design because we're running 2 different scenarios.
Yeah, okay.
You're not. Well, you're running 2, but I mean.
Sure. Okay. So.
But you're running.
I agree with you, and in some senses, these 2 are the core things that we'd expect people to do, right? Full stop. That's it. And anything else is to some extent optional. And I'd want to run lots of different stabilisation scenarios. Yeah. I suspect Ron and Jerry would want to run
because you're doing one that's much, much higher.
Yeah,
and then, you sort of want to. The others. This
if you provide the scenarios, we'll run them.
Yeah.
But in terms of what we're providing as a core, this is experimental design. We're saying that this is the minimum we want people to do. Mm-hmm. And the advantage of these 2 runs particularly is that it doesn't require. The experimental design is identical if you've got a carbon cycle or not.
Oh, the second one doesn't exist.
Yeah, you don't need the second one.
So I think I 1 and 2 I think are I think we're on the same page. I just don't find 3 particularly useful. I mean,
so where do ensembles come in for experiments 1 and 2?
Just run multiple realizations.
You could do them if you want to. You've got enough computing time.
But you just run multiple realizations off of.
Yeah.
You do the same scheme that you've used before.
When we spoke about this the other day in the long time scale scenarios thing, and I think we agreed that the long time scale, the ensemble variability is dominated by the physical climate variability, not by the ocean climate variability. At least or by the carbon cycle the carbon cycle variability. The carbon cycle variability. Let's say this again. The carbon cycle variability will be dominated by the physical climate variability. Okay, so if you need to span. You need an ensemble to span the variability in the physical climate system. That will do for the carbon cycle as well. I wouldn't bother though. Why because I don't think it. I mean, what will happen in this? I mean, one health warning is that when you diagnose this flux, because these things are changing every year, this flux will do all sorts of crazy stuff. This fossil emission flux, and it will need smoothing out before you give it to a policymaker. Because as Olivier said the other day, if you tell a policymaker you can emit 7 gigatons this year because it's a La Nina, they're going to wonder what you're talking about.
1 next year.
Yeah. I can't remember what I was saying now.
You read the noise in the.
Yeah.
Oh, the smoothing the.
Yeah. So the stuff that Working Group 3 will do will essentially be to fit those outputs to something much smoother. That's what we already do.
Well, we care about the cumulative effects. I mean, it depends. We can talk about what we want to diagnose. Because really, I won't want just fluxes. I want to know the underlying regional changes.
That's no problem, is it? I can do that.
You want some consistency in these fluxes for the model.
In terms of definition,
or in terms of this magnitude and variation.
Well, you want that, but you probably won't get it.
Well, that would be fun.
Consistency amongst models.
Well, consistency across models and consistency within the model. I mean,
Oh yeah, you get, well the second one you get consistency. Consistency and realism are
you
two
get
separate things.
by doing ensembles, you get some estimates.
I mean,
Yeah.
the models are going to be quite different, and perhaps drastically so. We'll see. I
But
mean,
you're
Yeah,
not
sure.
going to give a bunch of
Okay.
a spaghetti plot to
Right.
policy.
You'll get, I imagine that we'll produce some kind of envelope, right? Some sort of,
Right.
almost a PDF of.
I mean, we know that that's uncertain, so
Yeah.
you're not going to get consistency. Would be misleading.
What spaghetti plot you'll get is what the anthropogenic component was in these different stabilization scenarios. From the different
You would
models.
also
And therefore, what you would have to do, according to each model, to follow that concentration scenario. Right. Okay.
Yeah, Peter, I think this is a really good approach. But the one thing that one limitation I see is that when you when you hand back to working group 3 these fluxes so that they compute exactly what the allowed emission scenario really is for that model. The one option that's off the table is different land use changes, because the simulations are tied to that particular land use scenario that drove it in the first place. So you can't come back and say, well, if that's true, then I would have done a huge area of biofuels instead of
Well, there's two ways to deal with that. I mean, the one way is, of course, the integrated assessment models. That's what they're ideally situated to do. Is let's use this carbon cycle realization that matches this GCM and change the land use and see what that implies. And then the other one is, of course, you can do a variant scenario with different land use. If there's scenarios available with dramatically different land uses, you can try that to see how much change that makes. So
I think in some ways that's, I mean, is this going to come out in a report? I hope it does. For this to work well, you have to stagger working group 1 or working group 3 kind of activities. Maybe not reports, but certainly activities. And that sort of iteration goes round what is now half an assessment cycle, right?
Yeah.
Because we would diagnose fluxes that are completely inconsistent with what you've assumed in some of the models, and so the scenarios to reach that stabilization will become model dependent.
Yeah.
And you could imagine doing that, not within the IPCC, but within collaborations, and saying, well, what would you have to do in this model to reach that?
and
but what I'm saying, without going around again through the system model, you can't say that I would have changed the land use pattern, because now the original simulation is.
But
is
you
irrelevant.
can, because if you have some simulation in IAM or some carbon cycle in IAM that reasonably mimics what's in the GCM, you can explore that. I mean,
So you'd fit a reduced form model to outputs from these, and then explore.
I'll talk tomorrow. That's exactly what we're working on. So
that's predicated. I mean, that's going to work to the extent that the IM is similar to the system model.
Exactly. Now
you don't need you don't need to hand back to working group 3. I mean, if they're if the implied difference
but they're going
in
to be
fluxes is
different.
zero.
The thing is, there's going to be a range. The problem is, there's going to be.
You don't need their system model in the first place.
Well, the truth of it is, though, the process, the assessment. Sorry, do you want to go ahead?
Yeah, I mean, but the issue, you mentioned variations in biofuels. I mean, that's not going to be. I mean, there's actually a fair bit of there's actually not that much variation in the different models. I mean, we all have constraints. The real variation is going to be on assumptions of agricultural productivity and food demand population. So you can have two very different scenarios of technological change in agriculture population, and that's going to give very different land uses.
Okay.
And in one of them, you may have some land left over for biofuels. In another one, you may have very little.
Okay.
But the major land use, food dominates.
We did speak the other day about the possibility of having the reference scenario or two separate scenarios, one of which was one form of land use and one of which was another, sort of bounding the possible land use.
Right. And then
and that would
could
give
take
us
those two different and do experiment to see.
And that would at least bound it. So as long as the scenarios were in some way part of a storyline about land use, then we might be closer.
And for that matter, it would be even in terms of getting limited in computer time, which many groups will be. You could do your standard run, and then offline you could always put the other land use, scenario into your model, and without the feedback, how big that area is.
I mean, just to make clear, this issue of inconsistency is not a new thing. I mean, we've got it already. It's worse actually, in that we've got a 4-year assessment cycle, and people are using previous models completely. We haven't even got it staggered. So we might get a scenario of emissions, define a climate change, that's completely inconsistent with that socioeconomic scenario now.
Yeah.
That already exists. It's slightly more complex here because we want to do some other bits, but it's essentially the same problem.
Yep, I agree. But I just think it's important to note that that problem exists.
Yeah, and I think that's why we have to see this as an iterative process there's a leapfrog. The assessment thing becomes a leapfrog, WG1, WG3.
But the only problem with that is you're never going to really iterate this process. I don't think you're ever going to really iterate this process with the same Earth system model, because if you wait, 2 years and then another 2 years, and by then the Earth system model is different.
2 years.
Yeah, you're saying working group 1 and then 2 years later working group 3.
Models don't change in 2 years very much.
No, you're 4 years by the time working group 3 is done its job.
Okay, well, yeah, but it's working group 1, working group 2 years apart, right? Like that. That's what we'd be proposing.
Well, but you have to remember we're not just looking at GCMs. I mean, there's other Earth system models out there that we look at. So we're not going to be lagged by 5 years from what's going on. The whole point of these models is that they're flexible. At least some of the models are flexible and can update fairly rapidly. So
I think the other aspect to consider is that this is not necessarily tied to the IPCC cycles, because it's an initiative of the community.
Yeah.
And the first step already in principle exists. So when
Good.
you guys run the two first cases, then the integrated models.
I agree. I mean, it doesn't. Even though you
next
stagger the activity, it doesn't mean that the reports can't come out simultaneously.
I mean,
Although I do suspect that practically, unless there is a necessity to get the work done for a report, that we won't manage to maintain this 2-year interaction. But
I'm not going to wait till these runs are done to work on this stuff. I mean,
Good. Right.
But when this work is done, there'll be a coordinated, consolidated set of data that makes it really easy to take the next step. So.
Cool.
That's always clear as mud. Good thing you can leave town.
If I could have done
I
it,
would
would
have
have
done. The sheriff will look for you. That's good news.
Okay, so obviously we had the much more detailed and longer summaries from these two working groups. But what I was going to try to do was just kind of hit the highlights and maybe provide some kind of synthesis as to something that would actually be discussed at this meeting in September. So I think what emerged was that there was kind of two different classes of problems that we're talking about here. One is really on the shorter term, where we're really interested in getting some fairly detailed regional climate change information on the time scale of that's of interest to policymakers on the kind of 2030 time frame, which we've been getting this message already in the AR4, and we have actually more material addressing this shorter time scale in the AR4 than we've ever had before in any of the previous assessments. So we're kind of heading that direction anyway, but we haven't actually tried to explicitly address this shorter term time scale. We've just taken the global AOGCMs and looked at see what they say, at different times in the future. But it may actually be useful to really separate this out and look at the near-term problems with a somewhat different class of model, and this would be a higher resolution AOGCM, and this could be anywhere, and using this kind of rough class of model for atmospheric resolution, 0.5 degree to 1 degree or even higher resolution. And there's indications already that, for example, in Japan they have a working 20-kilometer global model that they, who knows, in a couple of years you may be using that as a coupled model. I don't know what would happen, but I mean the idea would be that there would be, this would be higher resolution, definitely, than what we're talking about with the Earth system models. So I think that was an important distinction that seemed to emerge that people thought was probably appropriate. And this for this time frame, and this exactly where this starting point would be, but somewhere mid-21st or 20th century, you'd have to do one of these kind of couple initialization and verification procedures where you'd want to kind of build in a long enough time period where you'd have the radiative imbalance between in the atmosphere, which would kind of portray this commitment idea, which we know now is really important for near-term climate change. And we'd also want to have enough observations where we could actually initialize, especially the ocean, to something that may be close to what the actual ocean state is. Now, there's a lot of issues with this. Ron pointed out from his experience already, yeah, that salinity is a particular problem for this ocean initialization. Salinity observations. And if you're trying to get the right state of the meridian overturning, for example, in the Atlantic, salinity is a big part of the density in the oceans. Obviously, that's a big problem to get the meridian overturning, the current state of it, get it right. There is hope that maybe with the Argo float data, which in theory will be providing a more global three-dimensional view of the actual state of the ocean, that we may actually be able to get those kinds of observations, but those obviously wouldn't come in until very late in this initialization period. So we may be able to nudge the ocean along with whatever XBT data or whatever we've got for some period of time, and then maybe right at the very end, as the salinity data comes in, you may be able to get a better. Peter's shaking his head.
Well, you don't want to nudge just the temperature without keeping the salinity constant, because most often temperature and salinity changes balance out in the density.
We got to nudge it with whatever observations you got, right? But I mean, there's people working on this, so I think this is something that probably will happen in one way or another. Yep.
In contrast to one of the requirements that the longer term goals had, which was to try to involve as many modeling groups as possible.
Right.
If it's something this complicated, you're going to get very few modeling
That's right.
groups doing
I think this is the idea, that there would probably be fewer modeling groups actually doing this. This would only be the modeling groups that have this capability. Basically, it would be the modeling groups that are doing this pretty much right now, which is maybe on less than 5. I'm not quite sure what that number is, but yeah, Ron?
All that seems fine. I mean, I see groups doing bits of this in all sorts of different ways.
Yeah.
I mean, somebody could do this with a low resolution, relatively low resolution model, kind of like an ESM resolution, and just look at the initialization and predictability without touching the aerosols or anything else.
Yeah. Well,
then you could go back at it with different parts of it.
Yeah.
So I was wondering if this is really going to be any sort of a common activity, or is this just a listing of activities that would be research activities?
Well, I don't know. I mean, this is something we'd have to discuss as we get further into this. I think this would be, the form this would take would be, if you're going to do this kind of experiment, here's a framework that you can do it in, and there may be other groups that are fitting in the same framework, so at least you have, you don't have 5 different papers with 5 different groups doing 5 different things and you're trying to make sense of them. You have some kind of framework that you give them, so if groups want to do this kind of experiment, they say, well, we want to do this kind of experiment and we want to make sure we're kind of doing it in a similar way. What are other groups doing? You say, okay, this is what we would recommend as a framework for this kind of experiment. That's my personal opinion.
Okay, but
Yeah.
I think it's important to ask how much of this is going to constrain, because there may be ESMs that would, for instance, I'm thinking about models that have highly resolved stratospheres that are not necessarily high horizontal.
Yeah.
Could they fit into this picture?
Yeah, and I think, again, these are recommended kinds of things. So ideally, for this kind of experimental design, you'd like to have pretty high horizontal resolution models, but I don't think you can exclude other groups that have other types of models. I think the important thing is you have some kind of initialized state. That's kind of a theme. And as we get down into this, then you'd have just a single concentration scenario for this time period. So we recognize that the different scenarios don't really diverge much in this time period. You can just use one scenario. Now, the question would come up as to who would produce this scenario, and maybe it'd just be some kind of an average of these 2 other ones that we're talking about. That would be kind of a low, which is like a B1 type, and a high, which is an A2 type. It'd be something in between that. But I think this we could get guidance on this from Working Group 3 as to what they would think would be a nice kind of mid-range. Do you think that'd be reasonable, Naki? That the Working Group 3 could actually recommend kind of a single greenhouse gas concentration scenario for this 30-year time period that'd be probably somewhere between this B1 type and an A2 type, somewhere.
Well, but if you did that,
it would be a funnel that's not too large by 2030.
Yeah, so they're just.
One can think that way.
But we're just going to use one concentration scenario, which we could get from you. Yeah.
I mean, the end result would then be that this time period would be using a scenario that the longer time is not reasonable.
Right, but it wouldn't make much difference because on this time scale, the scenarios don't really diverge much.
It's true, just the implications for the future.
Yeah, right. Yeah.
One possible variant on this that some of the models might want to do is we could, I mean, emissions corresponding to that concentration would also be available. You know, it's always possible there might be some models where there's something drastic that happens with the carbon cycle, you know, starts to happen over that period. And, you know, they would know that from the longer runs. So, you know, that's something that, you know, maybe if that's part of their, you know, higher resolution version, they might want to explore. But that's, you know, that's sort of obvious.
Yeah, yeah, and I think that, yeah, I think that's a good point. But I think that would be something you'd have to just see what the groups were doing.
There's another issue that I just wanted to raise. There is a large number of shorter-term scenarios out there that go to 2030 and never beyond. And those are very often used in the policy context, like the International Energy Agency scenarios. But they often differ from the ones that the modeling, the integrated assessment community does that go long-term. There is a little bit of a disconnect between the two time scales. And I would say, to generalize, that the emissions of those ones would be probably in the higher range and would not include usually the non-CO2 emissions.
Can you tell us how do they differ?
Well, like 50% increase would be a typical number over 2030. I don't know if Steve remembers some other numbers by heart, but it would be in that range. The new IEA scenarios they're just going to publish this fall have about 50% higher CO2 emissions than today by 2030. And that's in the upper range of the long-term scenarios. This is just for your information. So my proposal would be it would be more reasonable to take the funnel of the long-term scenarios rather than those short-term and just make some judgment call based by comparing the two, what would be the most reasonable trajectory.
And I think that, you know, in that case, it might be worthwhile to have a bit of an activity. Even, you know, informally would be better, but even, you know, formally might be too much of a pain. But, you know, we could do an evaluation of these long-term scenarios, these short-term scenarios from the different groups, and sort of decide, well, you know, maybe we should look at revising our long-term scenarios in light of this. So if there is a significant difference on average, you know, EIA and IEA and et cetera, you know, all have something significantly larger, that's something we should probably address. If there's just a spread, well, there's just a spread, and you know, it only doesn't have a large concentration consequences. So
Steve, the only point I was making is that the median of the short-term scenarios tends to be higher than the median for the same year of the long-term scenarios, but they're not outside of the range.
And do you think that's just because the short-term scenarios, those organizations tend to assume slower efficiency increases and less diffusion of the low GHG emitting technologies?
Well, that's difficult to answer, but my best guess would be that in the long-term scenarios we consider the outcomes toward the end of the century, the next generation of developments, whereas on the shorter-term scenarios, and that's the advantage of doing them, it's in some sense trend exploration with models. So they assume current efficiency trends, you know, current constructions of power plants and try to extrapolate that to 2030.
So it's probably a more, generally speaking, they assume a higher GHG.
Yeah. So Naki, if I can elaborate on this a little bit more, explore this a little bit more. I've talked with Steve about it, that I know there is this community of people like Tammy Bond and David Streets who are involved in both the historical emissions plus out to 2030.
Yeah.
Or 2050. Is this the same class of communities that are producing these kind of emission inventories that can differ from the ones that you do for the longer term scenarios?
That's a good point. No, I was not referring to that community, but it's a good thing that you mentioned that community. I would characterize that community as people who are doing both air pollutants and looking at the GHGs, and that's an emerging large group. And they're doing, many of them are doing shorter terms. We have a group at YASA that's doing the same thing to 2030. And I would say that should be included in this assessment as well, because the connection to air pollutants is becoming ever more important for the policymakers because of the possible win-win situations coming from both directions.
So our group has tried to make explicit that we think on the time scale of 2030 to 2050 that we would very much like to see some kind of an evaluation of how these emissions, these inventories differ, and what the potential implications of the difference are.
Yeah, well, that's something that Claire and I have been talking about to some extent too. Although I'll say that, like David Street's work, it's much more analogous to what we do, and our results are often when we stood up at the same seminar, and look, and they're pretty comparable.
Good. Well, that's only good news as far as
Yeah, and David Streets is also involved in our work at the ASA as well. So.
We had a meeting with the US EPA a few months ago, and their comment was that, at least at this moment, the EPA has plans for aerosol projections in terms of emissions, especially cutting down to 2.5. And none of these projections actually are getting into the future aerosol projections that other groups are doing. So they would like
they're not. Well, hopefully they're not inconsistent. We work with the EPA all the time. I mean, we
they
do
thought they
include these
were,
effects
actually.
in there.
They thought they were inconsistent. Anyway, it's worth checking it out.
But we have, by the way, the same issue with the EU. For example, the ASA is doing the EU pollutants and particulates emissions as well. And we try to fold those into global scenarios, but it's the same thing. It's a question of always catching up as the new regulations come up.
Well, the part of EPA that does long-term and climate is over here, and the pollution people are over here, and they do try to talk, but it's the usual sort of.
But I guess the idea is that we're just going to be using some single greenhouse gas concentration time series here that would be worked out with collaboration with working group 3 people, but we're not going to run several. This is just one, and it would be decided in some way. And the idea would be that we'd have at least a 10-member ensemble, because we're looking at short time scales with small signals and a lot of spatial noise. So at least 10-member ensembles seem to be a good idea, and more if people can run them. And then the idea would be that the simple chemistry and some kind of aerosol scheme would be active. There'd be dynamical vegetation. In this interpretation, it would kind of grow and die in place. So I guess there wouldn't be succession or biogeography. It would just, because those seem to be acting on longer time scales. Think that's appropriate, or do you think you'd want?
So your definition of dynamic vegetation sort of implies biogeography.
Yeah. No, I think what you say is just say no migration.
No migration.
Okay.
So, okay, no migration. Okay. So, I mean, that on this time scale, you figure that the vegetation is reacting, but it's not moving around or anything. And there's no carbon cycle in this because that's a longer time scale issue. Then,
Jerry, I'm sorry. As I recall from the presentation yesterday, there were 3 options, right, that you were thinking about in terms of model development. One higher resolution, one much more intense introduction of new, whistles in the models, and then this sort of a compromise, which does a little of both.
Yeah, so I think.
Was there a reason why you felt this particular approach was the best one?
Well, I think that was kind of what your recommendation was, right?
Yes. We felt that there was a push to do higher resolution, so we don't want to go just to the same resolution full carbon cycle. But if we did this, it didn't seem to make sense not to have the aerosol changes, basically.
Yeah.
So this was for the reasons that David expanded. This was what we actually thought was the best idea.
Yeah, so I think the idea was that Peter was kind of outlining it as, well, you could do it this way and you could do it this way, but maybe the best way to do it is some kind of compromise somewhere in between this. And, and the caveats here is that, this is not a specification. This is not, okay, you have to do it with this resolution. But the idea is you try to do higher resolution than you would for your system type model.
Well, and part of the reason for the second part with the aerosol is that aerosols and perhaps partially offline snapshot ozone, they're a couple of the, well, in my view, I think some of the strongest scientific justifications for doing these experiments over this period, because when you're doing the historical part, if you have improved aerosols with higher resolution, that gives you some, David brought this up, some possibility of perhaps improving our understanding of the aerosol forcing, which is a pretty critical problem. And then over this time period, understandings of projections of changes in air quality are pretty important, and high resolution helps that. So that's that's part of the reason why that was in there, because that would.
Yeah, and then this would be another requirement that somebody would have to provide inputs for, and Peter had the things listed that you'd need gridded time series over this time period of whatever you'd need for the chemistry and aerosol components, and I can't remember what those were exactly, but those were listed. So that'd be a requirement that, I guess, who would generate those types of things? Steve, do you think? Where would those come from?
Well, that's a good, I mean, that needs to be worked out.
Okay, would that be a working group 3 kind of thing?
Well, there's community out there that does some of this, and there's a lot of pieces. So the thing that we've been talking, Claire and Jeff been talking about, is that we really need some sort of, at least you get a good word, census of what's out there to figure out what's appropriate, what's, what would be needed to done to make sure history is consistent with the projections and so on. So that's really needs to be looked at.
So is there...
I mean, there's a lot of stuff out there, and it may be an issue of just selecting the right thing, putting it in the right format. However, it's almost certain that not everything that's needed is done or will be, is just sitting there. So
is there a some analog to Ames and WGCM in this kind of community, or would this happen within Ames, do you think?
I don't know.
I think in this case, you don't need only Ames. We discussed a bit with Cassie about that. You need also the community like language transport convention, because they run exactly on the same time frame, and they are, I think in 2 months from now they will ask exactly the same questions where it will come from, and everything is available. I would say even on 0.5-degree resolution, but we have to evaluate all what is around, because you have a lot of differences, and for AR4 we use one scenario that was provided, but there are many other ones because we didn't have time to evaluate them. But I think we really need to evaluate all that, because it's all
this
over
might
the places.
be precisely something that atmospheric chemistry and climate.
Yeah, could do, and we need IGBP on board, and we need IHDP, and we need language transport convention. I guess it's the 3 big bodies.
One of the ways which we tried to partition between Ames and this AC&C effort was on the timescales over which the problem is relevant, and we decided to work on the more reactive component rather than on the longer timescale.
So there is a group. This AC&C group does exist, and
well, it exists and it has never met yet. So we're trying to define it meets next week,
and
we're trying to define what our role is. So maybe this is helping to define.
Yeah, well, this is great. Yeah,
so presumably Kathy will be there for the first day, unfortunately. But
what we need, I think,
and Claire and I, and some other people.
To have some,
this is great. This is good. This is good.
Big bodies above us, in a sense, over all these different groups, who say you should meet, and so have some incentive for the group to meet.
Yeah.
Because for now it has never existed, because the assessments on pollution and air quality were on one side, on the climate on the other side, and it's the first time we really think that we should merge at some point. And I think now the groups are there. We need to find a platform.
So this is on the IGBP side?
Both
Not
IGBP-WC.
That's a joint.
Yeah.
Okay.
You can come if you want. I mean, we'd be delighted. I think we invited you, but you might have said busy next week.
So presumably there are 2 components. There's one group that meets to say what is needed, what modelers need. And then there's the other group from the emission side that says, here's what we can provide, or we understand what you need, and we'll try to get it.
Yeah. So I mean, I guess we're Ames and WGCM are on the side of saying this is what we need, and then a group like AC&C would be for this time scale and for these chemistry and aerosols. That would be a useful thing to have. Given these kinds of needs, they're the group that could do it. The other question about who does these things, we kind of keep referring to working group 3 is going to do all these things. Is there a working group 3 group that's kind of like this, that could do these types of things and provide these types of?
I don't think so. There's not. These are different communities, so I don't think this is. And for that matter, during SRES, it was an ad hoc process to produce gridded emissions, and essentially I did one version, and then the final version I gave all my stuff to folks over in Netherlands, and they did that. So, and that was sort of because it was done it wasn't planned in advance. You know, it was a much simpler version of what I do on a more not regular basis, but what I have done before. So I think that, you know, this is part of what needs to come out of this, is that to get the input you want, both for near and long term, really, we need to plan a little bit more ahead in what we need and who's going to do it. So it's not clear where that would be where.
Well, I would say this should come out of this meeting, at least some tentative recommendation, because many of the groups, like Steve, are already gridding some of the emissions, but for our own purposes.
And we want to make sure that the gridding is consistent with what is done for the historical emissions.
Well, that's the whole point. Yeah.
So I mean, it's possible that since you're now on WGCM, Naki, we could actually commission a subgroup. You could get some people in working group 3, and actually we could have a little working group on emissions that then would, we'd work directly with WGCM, and this kind of thing would be given up, and that could be done as a little. It may not require a whole nother organizational effort to form a whole new group. One doesn't exist.
No, I think it could be a subgroup of this activity.
Yeah.
And I mean, having Steve here, who has already done most of the grading last time around, and a few other colleagues, I think would be sufficient. It would be a small group.
I wanted to add also that at the end of November, the GEA, which is emission activity of AIMS, is meeting together, so it will be mostly at the scientist level in this case. But we will have people from different groups, and it's also a good occasion to discuss what is really feasible, not what we want to do, but in this case it will be really the people doing the stuff. And so we might need some more people from local industry. We have some people from YASA.
So these are emissions scenario type?
No, it's emission in general.
Oh, emissions constituents.
Yeah, emissions in general. So we have past, future, and so on.
Okay.
Do you know who is involved from YASA?
So Zeke Clement is in the steering committee of the activity. And we have a meeting of the steering committee first.
Okay, so maybe at this joint WGCM AIMS meeting, this could come up again. We can revisit exactly how this could work.
Yeah, and I'll be there, and I'll be at the GEA.
Okay,
so
good.
I'm sending you the agenda right now.
Okay, good. All right, well that's good. And then I think the other parts of this that for different aerosols, and this again would have to come out of maybe this ACNC, that you may want to do a few different options. So you may have kind of optional additional experiments that groups may want to do if they were provided with kind of low, medium, and high aerosols or other things. I don't know exactly if that's the right thing.
Other pollutants.
Other pollutants. Yeah. Okay. But basically, there's this idea of a few additional experiments to explore a little bit of a range of possibilities on this shorter time scale.
Because there's quite a bit of potential range on that short time scale on local air pollutants, and there's a lot very significant issues of what if China doesn't control and U.S. does? There's all these interesting things going on in this time scale, so that actually high resolution should help deal with in long range transport.
Okay. Yeah. The other kind of thing that was in the optional but kind of be aware of category is this idea of the geoengineering experiments. That really the only mitigation you could think of on this short time scale would probably come from geoengineering, and so there are some geoengineering ideas out there that are apparently
have a big effect on climate.
That would have a big effect.
Yeah. No, you have to start the mitigation, but that's just
talked
the wrong
already.
word.
Yeah, right. Yeah, sorry. Yeah. So anyway, that was another aspect of this that was kind of in the optional category. Okay, now we've just spent some time earlier this morning talking about the long term, but I think the general idea would be that these would be lower resolution AOGCMs, and they'd have Earth system type components in them, including carbon cycle. There's this idea that they'd be done in kind of the way we've done these before, with a pre-industrial spin-up, and then these 20th century forced experiments with natural and anthropogenic forcings, at least 10 members ensembles for the detection attribution community. So this is pretty much with the kind of conventional AOGCMs that we've pretty much used already. But these types of things would still be appropriate to kind of interface with these Earth system type models. And then I thought, which was really a significant achievement of your breakout group, was that you think that 2 benchmark type scenarios could be run. One, kind of like a reference or no mitigation, which would be kind of like an A2 type scenario, and one, a kind of a mitigation type scenario, which would be kind of a B1 type scenario.
Steve?
One thing to possibly consider would be, and I think it'd be a little easier and consistent to do the 2300 is, in a sense, an A2 or A1B, you know, some high emission scenario that is stabilized at a high level. And that way you get, over 2100, you essentially get the same, you will get the same climate change as the reference case, but then it's clearly defined what happens after that, and it's not arbitrary.
Yeah.
So what would be the high level B, Steve?
Well,
6-7 watts? Or
like
more?
750, you know, ppm per
750.
CO2 or something like that. I mean, we can take a look and, you know, recommend something, but that way it's very, the definition is quite clear as to what happens after that.
Yeah, beyond 2100.
Yeah.
But I think in any case, for the low bound, we should say stabilization, and on the upper one, I think if we agree, also do the same thing. But then it would be a very high stabilization.
Yeah.
I'm not sure how many off-the-shelf variants of that there are.
But that's
We
not
have
too hard to
look into
create.
that,
So
yeah.
it wouldn't have to be off the shelf for about a year or more.
Do you like calling this mitigation or stabilization? Does it matter?
I prefer stabilization in this
Okay.
case,
Yeah.
that we know what we
Because that clearly tells you where
Okay.
you're heading toward, and that's the FCCC language.
Okay, stabilization is better than mitigation.
Because mitigation is, you know, well, that can be all kinds of things.
Right. But I guess the so-called these new mitigation scenarios that Work Group 3 is assessing, I mean, you call them mitigation scenarios, right?
No, actually the working group 3 has the objective of looking at the stabilization in particular and mitigation in general.
Okay.
So there is a focus on multi-gas stabilization scenarios because that's the new stuff.
Okay. Yeah.
I was just going to say I agree with Steve. I think just from a policy perspective, it becomes less and less likely that people are going to be talking about non-mitigation, business as usual scenarios. And what we're really trying to figure out is what's the appropriate stabilization.
Stabilization, so that's the better word. Yeah, okay.
There could be a variant with a different land use for this stabilization.
Well, part of the point is these two would have quite different land use. That's why one's an A2 type and one's a B1.
You won't be able to isolate the effect of land use because it's quite different in terms of the CO2 concentration.
Well, but you could swap the land use changes to do the experiment. I mean, that's a way. I mean, that's a good research type run to do because then you've got the whole point, I believe, in this is to have two different land uses, and then you can swap them and see how big the effect it is.
So that'd be part of what's specified in the scenarios.
Right.
You'd have a land
Land 2
use
type and B1 type are going to have very different land use.
in addition to greenhouse gases, aerosols, everything else. Yeah. Okay. So, big numbers of ensembles may not be as important for these. So you have groups running at least one ensemble member, and if they can run more, then that's an option. But I think it's large number of ensembles isn't as big a concern with these. Obviously, you'd have carbon cycle and biogeography/succession active, and chemistry and aerosols would be prescribed, as I understand it. And then out to 2100 would be the nominal experiment. Then we were just talking about what you do after 2100. You may come up with like an A2 stabilization experiment that would go out farther.
Now, what's the rationale behind prescribing aerosols?
Isn't that part of the scenario?
I mean, emissions or emissions or loadings.
Concentration, or well.
Concentration, there would be a variety.
Yeah, there would be a variety again. Yeah, Ron.
Just like in AR4, we've had models I think that did it both ways, and I think I would envision models going it both ways again.
Yeah. So you'd probably start with some
both
emissions.
So you'd have the emissions available, and someone would make loadings available.
Yeah,
for
somebody like Olivier would be asked to do that again.
Right.
Yeah, you do it again. Okay. So Peter just gave a nice summary of these experiments, but the idea would be that there'd be these two experiments. Each of them would be run with the two scenarios, and as we saw here, this is one where you fix the CO2 concentrations so that the temperature responds in the atmosphere. The carbon cycle sees the concentrations and the temperature change, and responds with CO2 fluxes between the land and the ocean, but the atmosphere doesn't see those fluxes. You save those, take those off and save them. Then you do this experiment 2,
where you fix the atmospheric CO2, and that's what the climate system feels, so you get pretty much level temperature or some changes with variability around it. But the carbon cycle sees the CO2 concentrations from experiment 1, and therefore the carbon cycle is reacting to these CO2 concentrations, but not any temperature or climate change, and you save those fluxes. Then you can calculate the implied emissions in the way that Peter described here. So you have two different emission tracks from these two different, these implied CO2 fluxes, and the size of the carbon cycle. One, I guess, size of the carbon cycle feedback is the difference between these two emissions. But then there was this experiment 3, where you would take the implied emissions from this experiment, run it back in with the full interactive carbon cycle, and come up with a new set of concentrations and another climate change. And that difference then would be the magnitude of your carbon cycle feedback in your model. So that would be kind of for groups that have kind of all these things active. But the real attractive part about this is that if you're a group that just has an AOGCM, you can give them the concentrations, they can do an experiment and come out with a climate change just like the other groups. So you can widen the participation, and then the groups that have more system type components can do more things with this. So I think it's attractive in a number of ways. One way is we just have 2 scenarios. That's good, and they're kind of benchmarked, and Working Group 3 can relate those back to policy decisions, things like that. We can involve a wide range of modeling groups with different capabilities, and we can work in this kind of verse system model type methodology. It's short of full interactive, carbon cycle feedbacks and everything else, but I guess the advantage is that if a lot of these carbon cycle models may be a little flaky, and you may not want to you may want to do it in this way that's a little bit more controlled. Somebody still may say, well, you still don't have the full-blown thing, so that if you've got a huge feedback on temperature that's really going to affect the carbon cycle, that's going to affect the temperature, and you have some like an isobeta feedback, if it's an amplifying feedback, you won't get that. But on the other hand, you won't have runaway situations where you may get really strange climates.
Feedbacks are just,
yeah, feedbacks, but
the policy is here's our concentration target, not the path, not what our emissions path is. And the other good thing about that is that if one component of the model is a bit odd, you still get you're going to get a consistent comparison across all the models of terrestrial and ocean separately in a sense, and that's very valuable to me.
Right. Yeah. Ron?
Like I say, another advantage that comes IPCC time. Chapter 10 will evaluate all the models that have run, or all the inputs were the same. The rate of forcing is not exactly the same, but at least all the inputs were the same, so you don't have all these caveats going through.
Right. Yeah. So I think there's a lot of advantages to this. And again, these are designed to be community kind of coordinated experiments that still, individual modeling groups could do individual experiments with specifying emissions in different ways, or running different scenarios, or doing whatever they want. But those would be kind of in a different category. For these coordinated community experiments, this is probably a reasonable thing to do. Richard?
And just a question about exactly that point. I think there will be some complaining within the impact community about having only the 2. I think we can anticipate that. So the question is just a sort of informal one to the modeling groups. Are people likely to be willing to do something in between, as Steve sort of described? Because I think if there is something available, then we can say, on a voluntary basis, some groups will be doing this, and it will then help.
Just agree on what that is.
Right, and if we could agree on what that is, that would be even better. So then the impacts people would be able to have a slightly finer gradation.
If this is effectively stabilizing it, if we have a low, 400 ppm, and then the other one's, 750, 800, then clearly, we could do something in between. I mean, there'd be a lot of room there.
Would there be any reason, if you had a medium scenario, the cost benefit of running experiment 2, I would think, would go way down. If you did it with the high and the low, you wouldn't need to do it with the medium. You just need to run experiment 1. So it's only one experiment, one more integration for the addition.
Also, for the ones that we ran this time, the 3 different scenarios, I mean, the responses are really quite linear in the CO2 rate of increases.
Yeah.
So you could, without actually running them, you could have said what was going to happen.
Yeah,
but that's true of emission scenarios, which sort of just keep on going up at a certain rate like that.
The other reason for running, or at least having it available in an in-between scenario, is when you look at it, what do people talk about most as far as the scenarios that were given? They talk about A1B, not because it's the most probable, but because it's a mid-range. So if you say to people, hey, we've run a high and low, but not a mid-range, what are they going to talk about?
Well, that was actually came up when we were talking with Richard about this, is that we noticed from Working Group 1 point of view, probably 80% of the papers have been written on this multi-model data set have looked at changes in A1B, like you point out. Richard says, well, but for the impacts, you're interested in worst case, best case. And so, you know, for the kind of specified concentration experiment, it probably would be useful to have, and that would be kind of a reference. If you did kind of a mid-range A1B type, that would also reference back to the previous assessment. And that could be, you know, kind of this standard, this idea that kind of new standard experiments would be 20th and 21st century experiments, and the mid-range one would be a kind of a standard run. But that would be, this scenario group would have to generate a third, but it wouldn't be part of this. It wouldn't be part of this coupled or system model kind of experimental design. It would just be another one that could be run.
The implication of that, Jerry, is that the common experiment should be from the one scenario that's the mid-range.
Well, I think the problem here is that probably what we would suggest would be more than you guys would like to run. Yeah. So the real challenge is to figure out what kind of middle case to take here. But I don't think it's not an issue that it doesn't exist. The issue is how to narrow the options.
But I think for these, I mean, the questions we're addressing here are basically stabilization. That's different from a mid-range kind of thing. So I think you still have to have these as the community experiments, because that's kind of the point of.
There's no difference between over 100 years between some stabilization and some, you know, it just depends what stabilization level it is. I mean, if B2 is you know, the B2 from from the SRS, you know, the one that marker, that was stabilization at 550 or 600. I mean, you know, over the 21st century, they were, you know, that was essentially identical.
Yeah.
So you can specify a whole range, and you can specify them over 2100. It's sort of ambiguous whether it's stabilization or, you know, at certain levels or reference, and then that makes it consistent as to what you're doing after that if you really do care about this comparing this long term. But the other, I mean, which is a little radical suggestion in the sense of, you know, saying, well, it doesn't matter whether it's stabilization or reference. I mean, it really doesn't. So I don't know if that'll be acceptable to the political community. But and the other point, whether the real common experiment should be mid-range or low, that gives you two different things. If the common one is low, then that gives you interesting constraints on carbon cycle behavior and stabilization at a low level. If you do it mid-range, you know, you have more carbon feedbacks acting. So, you know, I don't know, in the mid-range, maybe that's more interesting scientifically in the sense of you have more feedbacks, and is that what you want to compare between models, or you want to compare a lower level where there's less feedbacks?
Well, isn't it, I mean, for what Working Group 3 is going to do to relate a stabilization scenario back to a lot of different policy kinds of things that have to be decided, isn't the low one the one that you really are most interested in, because that's going to take the most.
Depends which continent you live on.
I mean, if you think that
fair answer.
If you think the A2 type is just the business as usual, where there's no policy intervention.
Well, A2 type is a little bit odd because that's. I mean, I never use the word business as usual in anything I write because I don't think it exists.
Yeah.
And A2 is, you know, in a sense, it may be fundamentally incompatible with almost any climate policy. You know, I mean, for real, you know, with such low incomes, I mean, that's really problematic.
Mm-hmm.
You know, so, but you can have high emission scenarios and high incomes, and you know, then it's open whether there's a climate policy or not.
But Steve, it is conceivable even in A2 that in the long run, if people were still poor like in A2, but concerned with climate, that they could build nuclear power plants and use domestic biomass.
Yeah, well,
that's conceivable.
Yeah. The stretch.
But the idea is, I mean, for these so-called new mitigation scenarios that are being assessed now, I mean, a lot of them really are looking at stabilization at more of this B1 level, right?
Well, most of the groups did run stabilization cases based on A2. Most groups did do that. Now, you know, one can put this question of plausibility to the side, but they have done that as an exercise whether one can bend the model so far to actually stabilize in that kind of a scenario.
How about for B1?
Well, B1, yeah, the low stabilizations are usually derived from the B1 because there it's easier to achieve because you already have many of the policies that lead to relatively lean emissions for other reasons, and then you add some specific mitigation cases.
And then, you know, some of our CCSP work, it's, you know, the reference cases are somewhere in between B2 and A1. They're sort of a mix with some new assumptions, and you know, there's all kinds of possibilities. But you know, many of the possibilities from a GCM standpoint overlap. You know, they're indistinguishable in the noise.
Well, part of this exercise is to provide some that working group 3 has enough information from what we do. You can relate these back to a wider range of different scenarios, right?
But I think maybe the bottom line question we're coming to is we come to the conclusion that there should be a number of scenarios, probably at least 3 from the GCMs. Probably more than 3 maybe
too much,
start to become not significant, but probably at least 3. You know, a high, a medium, and a low one. And then the question from there is which one is the one? You know, which one of the 2 low ones, the 2, medium or low, do you pick for the common, Earth system model core that you want to compare to? And there's pros and cons both ways, and then maybe that's just the point that maybe we can't totally conclude that today.
Ron?
Just say, when we had the high and the low, and you're doing both, that seems very doable from a AOGCM point of view. We ran 3, most groups ran 3 scenarios, future scenarios for AR4. Doing the high and the low, we're asking them to run 4. There's these 2 each. Asking a few groups to do the medium doesn't seem to be a big deal if it's only, especially if it's only one run.
It's one run.
You only need to do that second run anyway if you want to diagnose the carbon cycle.
So a lot of people won't do that.
You might only want to do it in one of the runs. You might only want to do it in the high one, for example.
Or don't do it in the medium one if you do it. So then you're only adding. That seems, especially if it's optional.
Right.
Yeah.
You'll get the major groups doing it, and the other ones won't.
Yeah. Right. Dave?
And I think if working group 2 had their choice for a common experiment that everybody was doing, they'd want the high one.
Because the signal's bigger.
And worst case scenario.
Yeah. So the high and the low seems.
Yeah.
Make those the core, and then the other one optional.
Medium optional. Yeah. Okay.
But I think that we might want to consider exactly what type of high we want. Well, anyway, the problem with having A2 as a high is, people say, well, that's just, unrealistic and so on. If you have, sort of a, A1 fossil as a high, in some sense, that's more palatable. I mean, it's just
that
a
was
difference.
in our list yesterday.
Yeah.
I mean,
so it may
we're
be
just using A2 as a figure holder.
Right. Okay. Well, I would like for that not to be set in stone. That you have A2 or A1 FI type, and that way, because you may end up as you get up the chain, you may find that some people say, oh well, we can't have that. We got to have this one, this type, and even though it makes very little difference, maybe on the by 2100 in the climate model. Could.
Well, I think that's for your group to decide, because we're just looking for a high and a low. So the details are.
It's not just our group. There's political issues that come in, as we found out in SRES. So there may be some sensitivities. So
but just saying that he's going to give you the freedom to make those decisions.
Right. We're just going to in the report just put high and low.
Right.
List the particular.
And I think that you may want to call it something else. You may not want to call it A2. You call it just high. Yeah.
Okay,
high scenario for the OGCMs.
Yeah.
And then you
mean a lot more.
You don't associate it with anything.
Or we can label it with the stabilization level.
Or something like that. Any other issues, David?
I don't know if we really, I don't know if we really want to get into this, but Peter mentioned that part of the institutional pressure for the higher resolution run for the short term is to characterize these things now as real forecasts rather than sort of outlooks or projections or research activities. In a way, by not going to as fine a resolution as was desired, maybe that sort of allows us to wiggle out. But if it doesn't, do we want to take a stand on whether we think we're really capable of making real forecasts, especially on a regional level?
Yeah, I don't know if that word. I think Peter was being provocative by saying forecast.
He used the word prediction.
Yeah, prediction may be a better thing. Projection, I think, implies more longer term. Where you're not trying to. I mean, this always gets argued about what you call these things. So, forecast may not be the right word, because that implies you're trying to resolve individual storms and deterministic kinds of things.
But it implies that you've done some hindcast, so to show that you really have some predictability in the system.
Yeah.
And that also implies you put more effort on how you initialize, probably with some data assimilation techniques.
Yeah.
Well, the data assimilation was a key part of for the short term.
Yeah.
Different mode.
Yeah. So personally, I wouldn't use the word forecast, and may use the word prediction, but you
can do this data assimilation. The chances of you getting the state of the ocean correct are darn small.
Even if we knew what it was, right?
Yeah.
So we can use this general feeling that Peter does get that pressure.
Well, yeah, I think the idea that and pressure may not also be a correct word, but there's interest in various places, and we're getting it from WCRP to do more initialized kinds of things across different time scales. And I think that's reasonable in this kind of context where we're not doing numerical weather prediction with this kind of model. And that's a big, I think, distinction. Because we're doing, seasonal, interannual, and beyond at the 2030.
I guess the idea is the goal or the hope is that the community now is certain enough about what it's doing that on a 25-year time frame, it has a pretty good idea of what's going to happen regionally, because that was the point, regionally.
Right. That's the goal.
And do we think that's
But maybe we don't advertise it as if we have a pretty good idea of what's going on, but that this is the first serious effort that we make to do a regional characterization.
Yeah.
We don't know whether we'll be successful.
To explore whether that's possible.
Right.
Yeah.
Yeah, it's definitely research.
Yeah, and by the time we run these, because there's already things going on with this now, in the next 2 years, I think we'll be a lot farther along. And we'll actually have kind of maybe as a community come into some kind of agreement about how we actually do this. We started talking a little bit about this. Ron was saying that, well, maybe if, say, GFDL, Hadley Center, whatever group is doing some kind of assimilated product, they come up with some kind of assimilated ocean state that other groups could take and interpolate to whatever the model they've got and see how that works out. So there may be ways. Yeah. So
I'm going to blame Rosati. Why can't you?
Yeah, it comes down to Tony Rosati.
The key is that sort of experiment has already been done for ENSO forecasts.
Yeah.
And then they say, the part of the ocean that they need to initialize correctly is the upper tropical Pacific.
Right.
Now they're just advancing that to the North Atlantic plus longer term predictions.
Yeah.
And it's also been pushed a bit because of this seamless modeling idea.
Yeah, and I think it makes sense in this context.
But that's something that a lot of groups will be doing in the next 2 years.
That's
is the initial value problem.
Right. Yeah. So I don't think we're really out on a limb. I mean, it's a bit of a limb, but it's not totally out of the realm of what's really feasible and what people are going to be doing anyway. So I think a lot of these coordinated experiments, you're trying to capture what's already going on in the community and kind of coordinating it. So, we're kind of seeing what's happening and what's going to be happening over the next 2 years and trying to anticipate that. Okay, so why don't we break and.
Two slides.
Yeah, but that wasn't all the details though. So we'll have the break, and then whoever's putting together written material can work on that.